Okay, welcome back to McNab Chemistry. Today we're going to have a look at the trends in chemical properties of Group 2 elements. Group 2 elements, also known as the alkaline earth metals. Okay, the Group 2 metals then that we need to consider are magnesium, calcium, occasionally strontium, but most definitely barium. Okay, and then the chemical properties that we need to consider are their reactions with water, the solubility of the group 2 metal hydroxides, the solubility of the group 2 metal sulfates, and then we're going to have a look at some uses of group 2 metal compounds. Okay, so first let's have a look at how group 2 metals react with water. Okay, so there is a general trend with group 2 metals. Most group 2 metals react with water to produce the metal hydroxide and hydrogen. Okay, so for example, magnesium reacts with cold water to produce magnesium hydroxide and hydrogen. Okay, that's a slow reaction. Okay, and then calcium, strontium, barium, they also all react with water, okay, at room temperature and pressure, to make the metal hydroxide and hydrogen. Okay, so however, we need to look back at magnesium because it has some other reactions as well that you need to know about. Okay, so as we've just said, magnesium reacts with cold water to make magnesium hydroxide and hydrogen gas, and that is a slow reaction. However, magnesium also reacts with steam, and when it reacts with steam, this is a fast reaction, and magnesium oxide is produced and hydrogen gas. So that's important to remember. So magnesium reacts with cold water and it reacts with steam, and if it reacts with steam we get magnesium oxide, if it reacts with cold water we get magnesium hydroxide. And then calcium, strontium and barium all react with cold water with increasing reactivity as we go down the group, and they all react with water to produce the hydroxide and hydrogen. So calcium plus water makes calcium hydroxide and hydrogen. Strontium plus water, we would get strontium hydroxide and hydrogen. Barium plus water, we'd get barium hydroxide and hydrogen. Okay, next then we're going to have a look at the solubility of group 2 metal hydroxides. Okay, so the solubility of group 2 metal hydroxides increases as we go down the group. Okay, so magnesium hydroxide is only sparingly soluble in water, so magnesium hydroxide is only slightly soluble in water. Okay, calcium hydroxide dissolves slowly to form lime water, and then barium hydroxide is soluble in water, producing strongly alkaline solutions. Okay, so barium hydroxide, when you dissolve it in water, the barium hydroxide solid fully dissociates to make barium ions and hydroxide ions. So barium hydroxide is very soluble in water. Okay, we need to remember this. So metal hydroxides for group 2, so group 2 metal hydroxides, their solubility increases as we go down the group. So metal hydroxides, the solubility increases, hydroxides increases, high I. Yeah, metal hydroxides solubility increases, high I. Hydroxides increases. Okay, there we go. Okay, next then let's have a look at the solubility of group 2 metal sulfates. Okay, so this is the opposite to the metal hydroxides, which we're going to remember, aren't we? Because the solubility of the metal hydroxides increases down the group. So therefore the solubility of group 2 metal sulfates must decrease as we go down the group. So here are our examples. Magnesium sulfate is soluble in water, whereas barium sulfate is insoluble in water. Now we've come across barium sulfate before. You may remember back to GCSE chemistry where you could test for the presence of the sulfate ion by adding barium ions. Okay, and if the sulfate ion was present once you'd added your barium ions, we got a white precipitate of barium sulfate. So barium sulfate is insoluble in water. Okay, so if you remember there, that group 2, the solubility of group 2 metal sulfates decreases as we go down the group. Okay, finally then, for today, let's have a look at some uses of group 2 metal compounds. Okay, some of these are very useful to us in everyday life. So magnesium hydroxide, this is a laxative. Calcium hydroxide can be used by farmers to spread on the fields to reduce soil acidity. Okay, calcium oxide, that's quicklime, that can be used to remove SO2 sulfur dioxide gas from factory emissions. Okay, so calcium oxide plus sulfur dioxide makes calcium sulfite. Okay, calcium oxide is a metal oxide, so that's a basic oxide that reacts with sulfur dioxide, which is a non-metal oxide, so it's an acidic oxide. So if that's a base and that's an acid, it's going to make a neutral salt. Okay, CaSO3, which is calcium sulfite, SO3 2- is the sulfite ion. Okay, also calcium carbonate, CaCO3, can be used to remove SO2, so calcium carbonate plus sulfur dioxide makes calcium sulfite and CO2. Okay, again we can use the calcium carbonate to remove the sulfur dioxide from flue gases. And then finally, barium sulfate is a very useful compound because it's insoluble, as we've just discussed in the solubility of sulfates. Okay, but it's also non-toxic, which means that it can be used in medicine to create images of the bowel region. Okay, and this is how it works. You effectively drink some barium sulfate, so an aqueous suspension of barium sulfate is taken orally. Okay, it would then enter your intestine. Okay, go through your body and eventually enter your intestine. Okay, and because it's insoluble, it will sit around structures in your body. Okay, so when you shine X-rays on that structure, okay, the barium sulfate blocks out the X-ray. Okay, so the barium sulfate blocks out the X-ray. Okay, whereas the tissue around the barium sulfate, okay, won't block out the X-ray, and it will create an image, and it will allow you to see shapes of structures in your intestine. Okay, that's it for today. I hope that's been helpful. Thank you for watching. Please like and subscribe, and don't forget to click on the bell notification to stay updated.